You mentioned learning about the human brain to also figure out how to train a computer. Could you share a little more about what working in machine learning or AI looks like?
It can look many different ways for sure. I think kind of the two main paths are development and research. So development is much more applied, where you might be working at a startup and they want to train a recommendation algorithm for their company to recommend new products to a user. And with that, there's already a lot of models and that you can use. And then it's a matter of implementing them. So you're not necessarily doing anything novel, but you need to be aware of what different models you could use and what data you need to collect from the company in order to train the model. So, yeah, you kind of just need to understand some basics about training and testing models in order to do the applied AI. And from that, there's a lot of different algorithms online that you can take out of the box where you don't even have to code them. You can just essentially call an API that says train and run. So, yeah, kind of part of the challenge there doing the applied AI is getting it to work efficiently and getting it to work in production. And so that's making it work fast and then also being able to push it to a system without any bugs. So I think that's one area. And to me, that wasn't as exciting because for me, creating artificial general intelligence, which is a computer as smart as a human, is the most exciting thing about AI. So yeah, luckily I was able to get a job doing AI research right after college. And with that, it was initially applying AI to new domains that we as IBM hadn't been doing previously. So I was in the storage systems team, and with that, we were looking at how can we apply AI to helping storage administrators back up their data more efficiently, delete their data more efficiently so they can save storage, and then also to protect their data. So if they get a ransomware attack, can we detect the ransomware attack and essentially back up their data before that happens? In that scenario, we're looking at what models, like what data can we collect in order to do these different detection algorithms, and then from that, what kind of algorithms would we run on this data? Do we need to develop new algorithms to do this? And for me, mostly I was working on patents, so just like coming up with new ideas of how we could implement this and kind of designing a system around it. And that was super interesting because, like, I didn't have to do a ton of development work, which isn't always the most fun when you're dealing with bugs of programs. So that I like the high level thinking about that. And yeah, so that was kind of still applied, but a little bit research based because the like what exactly what we had been doing hadn't been done before. And yeah, also then got into some more theoretical AI teams while I was at IBM because that was kind of my goal to build AGI. So wanted to work towards that. And there I was working on a team where we are thinking about how to integrate Daniel Kahneman's the theory of how the mind works into AI. So if you're familiar with him, his book is called Thinking Fast and Slow. So he theorizes that there's a slow part of the brain and a fast part of the brain. The slow part is like your conscious thought, your logical reasoning, you're deliberately deciding, what do I want to eat today? Or like something along those lines. And then your fast thinking is kind of your unconscious that just has a gut reaction while you're driving. You're not even thinking about it, you're just doing it. So, what we were essentially theorizing is that in AI, we should have a fast and slow thinking as well. And then a lot of our discussions was, okay, what does that actually look like? What models should we develop for this? How do you switch between system one and system two thinking? When is one activated versus the other? So, yeah, we had a lot of questions about that. We're designing high level systems to essentially One have a fast thinking brain, which is essentially deep learning, where it kind of just goes through the neural network. The data goes through a neural network and you get an output, and it's not very explainable. And then we had a System 2 version, which was a symbolic AI, which does logical reasoning with symbols, and you can get some explanation from that. So, yeah, that was kind of the last team that I was working on. That's kind of the world of AI, I suppose.